All right, hello geometry friends, algebra friends. We are finishing up lesson 4, but I'm going to start from the beginning, do some review of our key terms that may help you, and then go through some of the questions just in case somebody was absent or wanted to go through them quickly again. But I will go through the ones we did in class quickly. The issue is I haven't taught this lesson to you yet, so I'm recording this before we do it in class, so I'm not sure how much we got through. So I'll just go through it all. You can fast forward as you need, and as always, pause if I'm going too fast, and you can rewind it as you need. So, some of the key features that we have talked about. Relative maximum, make common sense out of this. Maximum means the highest point, like a peak. Minimum, lowest point would be a valley. Smallest value, maximum is highest value. X-intercept, that's where the graph crosses the x-axis. A y-intercept is where the graph crosses the y-axis. There will only be one y-intercept because this is a function that must pass the vertical line test, so it can only cross the y-axis once. We may have several x-intercepts, but we will only have one y-intercept. Increasing is where our graph is going up the page, where the y values increase. That means your graph is going up, increasing, going up, decreasing, going down. Positive is where our graph is positive y values, so positive is above the x-axis. Negative would be negative y values, so a negative would be where it is below the x-axis. I think I said y-axis. You want positive y values, so it is above the x-axis. So positive y values are above the x-axis. Negative y values are below the x-axis. Special note, when you're talking about positive or negative, or whether you're talking about increasing or decreasing, when it is at 0 or changing directions, we will always use parentheses around that number when we're writing the integral notation. Okay, so let's keep that in mind as we move forward through our examples. So, first things first, x-intercepts. Where are the x-intercepts? Excellent question. The x-intercepts is where the graph crosses the x-axis, where the graph crosses the x-axis, where the graph crosses the x-axis, and where the graph crosses the x-axis. So this would be the point negative 3, 0. So at x is negative 3. This would be the point 1, 0. So when x is 1. 5, 0. So when x is 5. And 7, 0. So when x is 7. The y-intercept. Where is the y-intercept? Where does my graph cross the y-axis? Well, our graph crosses our y-axis down here at the point 0, negative 3. So that is the value of y is negative 3 at our y-intercept. The relative minimum. Minimum points means low points, the low valleys. The low points, low valleys would be right here when x is negative 1 and the y value is negative 4. And there's a second one, because we go downhill, meet the valley, uphill, that's a peak, downhill at the valley again. So that is our other minimum point at 6, negative 1. The relative maximum points, that's the top of the hill, that was up here. So that is a relative maximum point. Now, relative maximum points means we do not look at the ends of our graph. The ends of our graph, when drawn all the way out to the edge of our graph paper, that implies that our graph will continue on in the same direction forever. So when our graph is drawn to the edge of the paper, that means the graph continues on in that same direction forever. That's important to note because if our graph is cut off early, like for example, if I had something like this, where it just stops, then I know that my domain would start at this point. But if my graph goes forever, then I know that my domain comes from negative infinity from the left, does some wavy stuff, but then goes to positive infinity to the right. So that helps me with my domain, from negative infinity to positive infinity. Our range would be the lowest y value to the highest y value, but because of the ends of my graph go up forever, my graph comes down from a positive infinity for the y value, reaches a bottom of a valley, goes up, down, and then up forever. The lowest y value is this point here at negative 4. That's the lowest y value of negative 4, but eventually goes up forever. So our range includes the negative 4 for the lowest value, and then goes up to infinity. So I think we did that one in class. It makes sense that we would have gotten through that in class. So let's just go to the next example. Here we have a standard parabola from a basic quadratic equation. State the coordinates of the x-intercepts. Where does our graph cross the x-axis? Our graph crosses the x-axis when x is 2 and when x is 4. When it says coordinates, that means you will write the points. So the points are 2, 0, and 4, 0. Then state the coordinates of the y-intercept. So like I just said, when you're asked to find the coordinates, you're going to write it as a point. So let's see, y-intercept is at 0, 7. So that's the point we write for our y-intercept. Our domain is the x's. So our graph from left to right, what's the lowest x value? Or how far to the left will this go? Well, with the arrows at the end means it will go forever to the left, forever to the right. Talking and looking at the graph, we've got to think about it and talk about it coming from left to right. So it comes from negative infinity and eventually goes sideways up to positive infinity. So our domain is negative infinity to positive infinity. Our range is lowest to highest. So that means up and down. So our range comes from negative infinity, hits the lowest point, and then goes back up to positive infinity. So it comes from infinity as far as the height goes, negative infinity as far as the x goes, but it comes down from infinity, hits the lowest possible value of y is at negative 1, and then turns and goes back up forever. So the lowest y value is negative 1, up to the highest y value of infinity. Next, state the interval where the function is increasing. So increasing means our graph is going up the page from left to right. So increasing starts at an x value of 3 and then goes up forever. That is where our graph is increasing. So in notation form, we use the x values to describe where that is happening. That increasing starts just after 3 because it's coming down, 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 changes direction, and then goes up. So the change in direction is exactly at 3, and then it starts increasing immediately after 3. So when we write our interval, we use curved parentheses because it does not increase until after the 3, so we don't include it. But then it increases forever to the right. Decreasing, our graph is going down the page from negative infinity all the way until x reaches 3. So the decreasing section is at the left end of the graph, comes from negative infinity, and stops when x is equal to 3. When we get to an x value of 3, that's when it changes from going down to going up. So that's why we use the 3 here. Now, does this graph have a relative max or a relative min? Well, it's a U-shape. So that is a minimum point or the lowest point on the graph. So this graph has a relative minimum at the point 3, negative 1. Okay, example 3. This might be where we have to pick up for real. Let's see how it goes. Which points, A, B, C, or D, are relative maximums? Well, a maximum point means it has to be a peak or the top of a hill. So where are our maximum points? Where, oh, where are our maximum points? Where, oh, where could they be? Point A and point C are our maximum points. So that is what we will write. A and C are the maximum points because they are the peaks, the tops of the hill. Our points are our relative minimums. Our relative minimum points will be at the bottom of the hill. They will be at the low peaks, low valleys. So we have a peak up here, then it gets low. Then I have another peak, then it gets low again. So our valleys, our minimums are at point B and point D. Okay, so now we talk about positive. Where is our graph positive? And then we'll talk about where is the graph negative. Well, positive will be when our graph is above the x-axis. Above the x-axis, like where grass grows. Okay, grass grows above the x-axis. That's why I'm using green crayon to show you that all up here is above the x-axis. This is where all the y values are positive. So the y values are positive when we are in the graph, above the x-axis. So up here is where our graph is positive. So what sections of our graph are above the x-axis? Well, from 0 until 3, that is a section of our graph that is above the x-axis, from 0 to 3. So what other intervals have this graph above the x-axis so we can say that it's positive? Well, we named our first interval from 0 to 3. The next one is going to be from 6 to 9. Remember, we do not include when it's actually at the x-axis. That's why it's curved parentheses around these. So 6 to 9, it is also above the x-axis. And then from 12 on up forever, it stays above the x-axis. So all of those three different sections above the x-axis get their own interval when we write it out. Okay, those three sections where it's above the x-axis, three sections where it's positive, three intervals, one for each. Where the function is negative, that's going to be below the x-axis. So I'm going to color that a nice shade of blue, like going underwater. So down here, this is where the y values are negative. And when the y values are negative, that means our graph is negative. So when it asks for positive versus negative, we're talking about the y values on the graph. Is it above the x-axis or is it below the x-axis? It's almost like the humps of the Loch Ness Monster sticking out of the lake. Okay? So the positive will be where we actually see the back of Nessie popping out of the water. And then the negative is when Nessie is still in the water. So Nessie is in the water from negative infinity up to that point of 0. And then Nessie has some part of her body underneath the water from 3 to 6. And then Nessie has the last part of her body under the water from 9 to 12. So that would be our three intervals for our negative function. It's underneath the x-axis in three different sections, so we have three different intervals, one for each. All right, doing well, moving along. Now we have a little bit of a zigzag type looking graph. So let's see what we have to do here. Label any relative maximum with an A. So a maximum would be a highest point. That'll be right here. Positive and peak. Relative minimum point with a B. So the B with a minimum is going to be down here. Happens to be negative, but that doesn't matter, but it happens to be negative. And that is our low point. That's the minimum. How do we know this is a function? Very simply. Every x value maps to only one y value. Every x value maps to only one y value. That's what we write. Love it, memorize it, be able to write it as often as I ask you to, please. Domains. There's no arrows at the end of this function, so the lowest x value is negative 5, and then the highest x value is positive 5, so our domain goes from negative 5 to positive 5. Closed circle at each end, so square brackets at each end. Our range would be our y values, lowest y value to highest y value. So our lowest y value is over here at point B, that's at negative 4. And the highest y value is up here at A, and that's at positive 2. Again, square brackets because it can be equal to. Our y-intercept. Our y-intercept is going to be where our graph crosses the y-axis. So our graph crosses the y-axis at the point 0, -1. The x-intercepts. The x-intercepts are where our graph crosses the x-axis. We have one there, and the third one over here. Those are the three x-intercepts. So the x-intercepts are at 1, 2, 3, close to -4, 0. We'll do that. And we had -1, 0. And at 5, 0. All right, increasing and decreasing. So we are increasing when our graph is going up the page from left to right. So we are increasing when the graph goes up the page from left to right. We are increasing when the graph goes up the page left to right. So we have two zones where this is increasing. We use the x values to describe where that is happening. So from an x value of -5 to an x value of -3 is the first zone where it is increasing. And the other zone where it is increasing is an x value of 3 to an x value of 5. So that is our increasing because it is going up the page. Decreasing. It is decreasing when it's going down from left to right. So it's decreasing from point A to point B, decreasing from an x value of -3 to an x value of +3. So our decreasing interval is from when x is -3 to when x is +3. That's where it decreases. And now we get to positive and negative. Back to the old, let me highlight this thing. Above the grass or under. So above is going to be anywhere the y values are positive. Okay, so up in this zone here is where my graph is positive. It's considered positive y values. So the parts of the graph that fit into that zone is this pointy part here that goes from -4 to -1. The x values describe where it is positive, and it is positive from -4 to -1. Next and last, where it is negative. So where is our graph less than 0? Our graph is less than 0 when I'm below the x-axis. So what I'm looking for is the intervals where my graph is anywhere below the x-axis giving me negative y values. So in interval notation, based on the y values, my graph is negative from -5 to -4, -5 to -4, negative again from -1 to 5. So the rest of the graph is below the x-axis, and that's where our graph is negative, where it's below the x-axis. All right, one last problem. What I'd like you to do is pause the video, answer as many of these as you can, and then start it back up, and we'll see how you did. Pause the video, answer what you can, and then start it up, and I'll explain whether you're right or not, show you whether you're right or not. Hopefully you're right. Hopefully you pause this, answer some questions. Now you're just waiting for me to shut up and do it. So I'll do that. When our graph is drawn all the way to the edge, that means it goes forever. So that means it goes forever to the left, or technically comes from -infinity from the left, comes from the left to the right. The arrows means it is going forever and ever. And that means our domain is -infinity to infinity. Now, the range, that's high-low, up-down. The range shows that I'm going up. Its curve goes slowly, but it is still going up and forever down. So our range is also -infinity to infinity. As far as up and down is concerned, this graph will go down forever to reach negative infinity for the y values, and this graph will go up forever slowly, but reach positive infinity eventually also for the y values. When is this graph increasing? Well, when does this graph, as we trace it from left to right, when does it go uphill? And the answer is never. It doesn't. It's decreasing the whole time. And if it's decreasing the entire time, that means our decreasing interval goes from negative infinity to infinity, because the whole time it's going down from left to right. Where is this graph positive? So positive would be where it is above the x-axis. So it is positive everywhere up here. This is our positive zone. So our graph is positive from negative infinity to the point where it hits the x-axis. So that point is when x is 2. So our positive interval is from negative infinity up until 2. Our negative interval is when our graph is below the x-axis. So negative would be everything down here, this way. So our negative interval is when we pass the x-axis and then down forever that way. So it is negative from 2 to infinity, because it does go sideways as it goes down. So as x goes towards infinity, as our x values go toward infinity, this graph stays below the x-axis. Is there a minimum or a maximum? So is there a peak or is there a valley that we could label or identify? And the answer is no. There's no peak, there's no valley, there's no hills, right? Just constantly decreasing from one to the next. There's no waves, no roller coasters, no Loch Ness Monster humps or anything like that. The x-intercept, where does our graph cross the x-axis? Our graph crosses the x-axis right here. That is at the point 2, 0. Where is our y-intercept? Our y-intercept is up here at the point 0, 3. And if you have all that in, then you are done with this unit. Now when you come back, we will review and then test. And I miss you guys. Stay safe. Be well. Well done. See ya.